computer. There we go. All right, so it is Thursday afternoon, 2:03. It's science time, and we started out the hour by watching a little video of some sound vibration waves, because sound energy is interesting energy. Like light, it travels in waves. We feel them as vibrations. If you take your hand and put it on your throat and say la 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 la, you should be able to feel vibrations in your throat from the sound energy. You're producing energy. You're like a little electrical factory producing some energy. All right. So today we are starting a new science lesson. Remember, I told you we were kind of hurrying through Mod 5 in energy because Mod 7 is also about energy. So today, if you look on our, guess who did not remember to close the video? Whenever I don't close the video, this is what happens. All right, go back to this one. So
why are breakout rooms open?
Because there's a book club in there right now finishing up. So if you look at today's assignment in science, it's to do the lesson 503. You don't have to submit anything today, and tomorrow. Oh, you don't have to submit anything tomorrow. You don't have to submit till Monday. And actually, the things that you're going to submit for this lesson, if you are, I'll show you what I wrote on the schedule. I wrote that if you're coming to in person, you don't have to submit it because we're going to do it together on Thursday morning. It's a sound energy experiment with glasses of water. So we'll play around with that Thursday morning. If you're not coming to in person though, and you want to go ahead and do the experiment at home and turn it in, that's great. It's due on Monday. And then these 3 lessons next week, 504, 505, 506, I'm not going to have you submit anything. We're just going to go through the lessons. So if you're not coming in, you're going to need to go through those on your own time. 503 today, let's go to that one. And if you were having trouble with your Canvas, everybody seems to be having trouble with Canvas today. I'm not having trouble right now, but if any of you were having trouble earlier, that's because the site itself was down. So
oh, really?
If it was driving you crazy, that's why. I think our class was actually in at the time that everybody was emailing and saying it wasn't working. So I think if you get in and you don't sign out, you're in pretty good shape. Hi, Noah, did you have a question?
I'm not going to make it to book club.
Well, that's a bummer, buddy. But okay, make sure that you go on and do the reading, okay? Okay, so the sound energy one is only 6 pages, and it's all about the energy of sound. Did you know sound was energy? Kind of weird, huh? And they use sound to produce energy sometimes. Who can produce more sound energy? It's an odd question, but the answer depends on which one is louder. Interesting. Dog or cat? The louder something is, the more sound energy it has. Likely, a loud barking dog has more sound energy than a softly meowing kitty. But who knows? Maybe this kitty has a roar packed with sound energy. I think Vivi has cats packed with some sound energy. I think she told me she has Siamese kitties that are talkative. What will I learn in this lesson? I'll be able to investigate sound energy, describe sound energy, plan and carry out scientific investigations, and identify a control group and explain why it's important. Maybe on Thursday next week, we'll have a contest to see who can produce more sound energy. Maybe.
Easy. Okay, I'm gonna grab my trumpet.
No. You have to do it with your voice. La, 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 la. Page 2, energy for the ears. What do speakers, a person's voice, and a drum line have in common? Here's a hint. It has to do with a certain type of energy. Doi. They are all sources of sound. They take one form of energy or another and transform it into sound energy. Sound, like all forms of energy, is not something you can touch or see, but we can study its sources and how it affects other objects. Usually those objects are our ears. Let's learn a little more about what sound energy is and where it comes from. Good vibrations. A vibration is the repetitive movement of an object back and forth. Think of an elastic when you pull on it and let it go. It moves back and forth in quick, rapid movements. These are vibrations. Vibrations create sound. Sound energy travels in waves through substances such as air, water, or solids. Although, have you ever tried to talk to somebody under the water in a pool? Has anybody ever done that? No? Yeah? How did it work, Sasha? Could you talk to somebody?
Kind of.
Kind of. Does sound travel as well underwater as it does in the air? But it does travel for a long way. So underwater, if somebody's tapping a watch, like at the other end of the pool, you can usually hear that, but you can hear clicky sounds. You can't really hear the modulations of sound. Each of these substances is called a medium. The wave moves up and down just like the vibrating object that made it. The pattern of the waves or the vibrations can change depending on the speed. When the pattern of the wave changes, that's what changes the sound. Pitch. Different objects make sounds at different pitches. I will tell you that in in-person school, and I don't know if I remembered to record, darn it. Did I or did I not? Oh yeah, I did, yay. In in-person school, we had this one project in 5th grade where the students all made their own instruments and created an orchestra out of found objects, things like, glass bottles, things that you blew on, things you whacked. They made their own guitars with rubber bands. And then everybody got to play all at once and we put on a concert for the school. I have to say it was not the most beautiful music I've ever heard, but it was really fun. Different objects make different sounds at different pitches. Pitch depends on how fast or slow an object vibrates. The more vibrations there are, the higher the pitch. The less vibrations there are, the lower the pitch. The cello, for example, has big fat strings that vibrate very slowly. Does anybody here play cello? Or bass? No? We don't have any cellist. These slow vibrations allow it to play very low pitches, so it makes a low sound. The violin, on the other hand, has thinner strings that can vibrate faster. As a result, it can play pitches that are much higher. I'm picking up good vibrations. Sound energy is all around you. Every time you hear a sound, whether it be the annoying tapping of a pencil. Oh, wait, I skipped. Sorry. No, I didn't skip. Okay. The annoying tapping of a pencil or the satisfying slap of a high five or the unexpected rapping of someone's knuckles on the front door, you're hearing vibrations traveling in waves. Those waves are sound energy that's just waiting to be heard. There's so many examples of sound energy around us. Right now in the chat, please put in one kind of sound energy you're hearing right now. Listen and see what you hear.
I don't.
Nice. Construction, cars. A honking, good. Siren, excellent.
I don't hear anything.
Nothing at all. You can
People.
hear me talking. So when you're talking, if you try to go a bit too high, just try to do it slowly because you need those fast vibrations. Wind. Max ringing. The Max train, Amoy? Nice. Talking, yes. Okay. So we don't have to do that science notebook part. You don't need to do that. Sound practice. Just like other types of energy, sound energy can be transformed or changed. For example, using a speaker, electrical energy can change into sound and sound can change into kinetic energy. Let's explore some more examples. Have you ever wondered like how all those sounds can come out of your tiny, tiny phone? Kind of crazy, huh? Did you know sound energy has some unique characteristics? One important one is that it needs a medium in order to travel. So what does that mean? Does that mean out in space you can hear anything much? Like, could you hear each other talking in space? Do you think? What do you think, Amadi?
Oh, yes.
You think yes? For one thing, you can't just talk because you can't breathe out in space. Sound can move through
I
a
thought you were talking about with the astronaut suit.
Yeah, but I think they have to have speakers in them. I don't think that sound will travel through a vacuum like that. It has to have something in it. Sound can move through a solid, a liquid, or a gas, but it cannot travel through empty space like heat and light can. On Earth, our atmosphere has enough gas particles for sound to travel, but in outer space, it does not. So have you ever thought about outer space? Like it must be really quiet out there. There's no sound. Of course, there's sound inside the space shuttles because inside they've put air, so it has a medium. How is sound energy transformed? Select each of these examples to learn more about where the sound energy comes from and where it goes. So I heard about people who pay money to go into these hyperbaric chambers that are completely sealed and there's absolutely no sound inside of them. And they pay to get locked in there for a while. I don't know why. It's kind of weird. Okay.
Why would you even do that?
A guitar works the same way all string instruments do. When the string is plucked, it vibrates back and forth. This vibration creates a sound wave in the air around which it travels into your ears. For an electric guitar, the vibrations are picked up by a device, which converts it to electrical energy that's sent to an amplifier that makes it louder. You can really make a lot of noise with guitars, speakers, wind chimes, and your voice. Let's see what is, oh, that says speaker.
Switching.
Here we go, speaker. Nowadays they've made speakers so small, they used to be gigantic. Electrical energy is sent into the speaker, which causes the middle of the speaker to vibrate. This part of the speaker is called the diaphragm, just like where we can increase, like opera singers use their diaphragms or their core to sing. La, 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 la. Try to use your diaphragm and talk right now. Try to speak from your stomach. La, la, la. Right? As the electrical signal changes, the way the diaphragm vibrates changes too. This, I don't know why it's overlaying like that. It makes it very hard to read. I can go here and read the text version. Oh, maybe not. It's not going to let me. Wind chimes. Who has wind chimes at their house? Anybody? No? Wind chimes also take on vibrations, and according to how long they are, they make a different pitch. And then our voice. Look at that. There's the singers. You know, when you're singing, you can kind of make your voice do that vibrato thing where it goes la, like that, like the little pig in Babe. Those vibrations, when you make more of them, it's one of the things we like in people's voices. All right, here we go. And people are having trouble with the internet right now. I can see lots of messages popping up. Search for each of these examples by selecting them one at a time and selecting the search button. Review the search results for each example of sound energy sources. Select the ear icon to hear the sound. Okay, let's see here. How come? Oh, digital alarm. Search. Oh, there we go. Well, that's a pretty silly way to search, isn't it? You guys know what that is. Let's see how come it's not making, oh, here we go. Oh, lovely sound. Please stop that.
Snooze.
How do you switch it?
Click on start over.
Oh, you have to start over each time.
Yeah.
I do want
No,
to.
I just take out the other one and put in.
Oh
the-
yeah. You
When I was a little girl, Amzi used to have this giant heart. It was like a cave that you walked inside the heart to see the different chambers, and it had that heartbeat sound. But I don't think Amzi has that anymore. Believe it or not, your heart is the source of sound energy. You may not be able to hear it right now, but doctors use a stethoscope to hear the vibrations your heart makes. How many of you have ever heard your own heart?
I have. My dad. I think my dad owns a
Stethoscope?
yeah.
I just listened to my heartbeat because it was so quiet. I could even hear my heartbeat.
Yeah, sometimes underwater you can hear it too, or if you run, it kind of pounds in your ears.
Yeah, you can hear it like.
Let's see, start over. Let's do the glass breaking because that'll be kind of fun.
It's the sound of glass breaking again.
Here we go. Ready? Oh, that's a bad sound.
Wait, did we do heartbeat?
No, I did heartbeat, but I didn't. Do it.
I've heard that. I've heard that noise a lot.
Uh-oh. Has it been your fault that you've heard it a lot?
Maybe.
Have you ever seen someone play music using glasses of water? Have you guys heard that? Have you ever seen that? I'm going to look because there's this one woman who's really famous.
Is it like they use their finger and like what do I say?
Here she is. Let's do this one. These guys have glasses of water with different amounts of water.
It was an actual instrument that Mozart wrote for. I'm a clarinetist. I play Mozart.
Right back, I'm gonna go get his water. Pretty amazing, huh?
How did they do that?
Have you tried it with the glass? What it does?
I know those. I've seen those.
Listen. Wait, I gotta hold it against this.
Yeah, it's very fun.
If you try this with a glass at home, it has to be a certain kind of glass, and it starts vibrating, is what it does. And if I put
What
different
kind of glass do they have to
water in,
do?
it works best with a wine glass, but you can do it with different kinds of glasses. And you should just try it. You just move your finger, but not too quickly. It has to have water. It has to be a little bit wet. And then, like in the air, it doesn't work as well, although it's working. Works better if you.
It's really quiet.
It's kind of fun. You can become a glass person who does glass music. All right, so this guy was amazing. He was amazing at his glass stuff. But let's go back to our unit. Oops, that's not it.
What's Mozart?
Mozart was Amadeus Mozart was a really famous person who wrote music. All right. Have you ever seen someone play music, fill up the glasses with different amounts, and they make different sounds? So this is the experiment here. I will bring wine glasses and some other glasses so you can play around with this next week on Thursday, or you can play around at home. This is actually the homework for this lesson, is to fill this out. Like I said, if you come in next week, you don't have to do this on Monday, but if you're not going to come in, please work on this. It tells you to have 4 identical glasses and a fork, and you label your glasses and then fill them different amounts and then play with them. So, and in this case, I don't think they have you rub on the edge. I think you have them tap it. You tap it with a fork to listen to the sound. Please don't break the glasses. They do have to be glass. They can't be plastic. Okay. So again, if you want to do that one on Monday, you can, but if you are planning to come in, you can skip it until Friday and just bring your workbooks in when you come in on Friday, and we'll do several of the experiments. Did you know animals use sound to see and find things? Maybe Vivi can give us a fact about this tomorrow. Sound energy can do more than just give us something to listen to. Animals use it to help them survive. Dolphins use sound waves that they send through the water to help them find food and detect predators. Bats use sound waves to help them fly around in the dark. In both cases, the sound waves bounce off other objects, and the dolphins and bats use the echoes to figure out how far away these objects are. This skill is called echolocation. So if you hold your hand up in front of your face and talk, and then take your hand away, you can tell that something's in front of your face if you have your hand there, because the sound bounces back to you differently. Give it a try right now. Talk and then put your hand in front, and then talk again and put your hand in front. That's echolocation. We of course don't have very good echolocation. People don't, but some animals have amazing echolocation.
Yeah, like a dolphin.
Or echolocation. I'm not sure how they pronounce it.
Echolocation, yeah.
What did I learn in this lesson? Light energy can dazzle the eyes. Heat energy can keep out the cold, but sound energy can make breathtaking music. When something vibrates, it sends out a sound wave that travels through the medium it's in. If that sound wave hits your ear, you will hear a sound. The sound you hear will depend on the object that's vibrating. Fast vibrations, usually made by smaller objects, create high pitches, while slower pitches made by larger objects produce low pitches. Now that is some swinging energy. Rock on. Here's a self-check review you can do if you would like to. I'm not going to go through that right now. I just thought for a fun last thing, we would play that guess the sound game. So here it, not that one, not that one. Oh, look at the rainbow paint on a speaker. That's cool. Here's the guess the noise. Are you ready? So get your chat open so that you can put in what you think it is. Are you ready? Yes. Here we go. First noise. Stop it. Let's see here. We have rain, waterfall, TV. Yeah, I'm not sure what that is. Maybe, yeah, a river. Not sure. Rapids. Okay, let's see what it is. The answer?
Oh, it's good.
Car wash.
Oh!
That's interesting. Okay, I don't think anybody got it, although they knew it was water. Here comes the next one.
You can get like half a point.
Half a point.
No,
Number
it's-
2. Oh, lawnmower, leaf blower,
Sounds like a chainsaw.
truck engine, lawnmower. Yay! One for us. We got that one. Number 3. Huh.
Sounds like a
Dishes. Oh, I think you're right. A laundry thing, a clothes washer. You're
Oh.
right. Good job, Brianna. You got it. You could hear it at the end when it started doing that swishy thing back and forth. Number 4.
oh. Yeah, I wonder. Yeah, I wonder.
Okay, that's annoying.
I wonder.
That one was too easy. Train whistle. Oh, it was a toy train whistle.
Well, that still counts. Thomas and Friends. That was my childhood. Thomas and Friends. You done?
Oh no. Here we go.
It's a keyboard.
Keyboard.
Has to be a keyboard, right?
Computer keyboard. You totally
Yeah.
nailed that one. Good
Imagine if it was a typewriter.
Okay, that's enough of that. That's enough of that for today. All right, at 2:30 in 4 minutes, we have the Untitled Book Group with Amadi, Kainoa, Liam, Jax, and Lauren. Everybody else, you can take off. Have a good afternoon.
Bye.
I will put you guys into room 2. How's that?
One more riddle for today.
I never closed this. You have one more riddle?
Yeah. I have to do Okay. A man is found unconscious in front of a store at 2 in the morning. His head is hurt, and there is a brick laying next to him. When the police arrived, they carried him to jail.
What?
Why did they arrest him?
Say it again.
A man is found unconscious in front of a store at 2 in the morning. His head is bleeding, and there is a brick laying next to him. When the police arrive, they carry the man to jail. Why did they arrest him?
I don't know. Is it because he was trying to break
Wait,
in?
are you talking about like 2 in the morning or like 2?
Yeah. No, he's talking about 2 in the morning, I think.
Then
I think he was trying to
store
break
hasn't
in.
opened yet. The store hasn't opened yet, so he broke in, and the glass probably made him bleed.
Like
But
trying to get out.
if he tried to break in, why is there a brick laying next to him then?
Because he was throwing the brick through the window.
He tried to break it. You got the break-in correct, but that's not. But the break into the window is not the correct answer. Reason.
What is it?
Break into a house?
So, you got the correct answer. He was trying to rob the store. The reason why he was unconscious is because the glass was bulletproof. It was bulletproof.
Oh, because it bounced off and hit him in the head.
Yeah.
Okay.
So I'll give you like a quarter.